Okay, let's talk about Python variables. Okay. Basically, a variable, if we look in Python, and I'm going to be doing this interactively at the command line, so there's going to be a little prompt with 3 arrows, and I'm going to type in something like a equals 2. And in the memory of the computer, memory is basically a big long thing with a whole bunch of addresses that start out at 0, 1, 2, and eventually it goes on up to some big value, usually billions of locations. But in the memory of the computer, A is associated with some memory location. And inside that memory location, we're going to put a 2 at some point in time. Now, everything that happens with variables, the stuff on this side happens first, and then it takes the value and it puts it over there. So this equals is not like an algebraic equals. It's a do some stuff and put it in. So if I later say a equals 3, then I go out here and I erase the value 2 and I put in a 3. So that later if I say print a, I'm going to get on my output over here a 3. Now, somewhere in here I'm going to do something like a equals a plus 2. Now, in an algebra thing, a equals a plus 2 is a contradiction because a can't be equal to a plus 2. And that would be something like the statement false. It's broken. It's not true. But here, remember, this happens first. So we take a, which is 3, we add 2. So we do 3 plus 2. 3 plus 2 results in 5. So we take 5, and we come over here and we put 5 in. Now, the advantage to variables is it allows us to build some piece of code that we can then put data in and run over and over and over. You remember the tiny little example with Excel. We had 2 variables in A1 and A2, and then we had a calculation that we put in, like, I don't know, some calculation. A times 2, I think, is what we put in. A1 times 2, or something like that. But we did a calculation. And that calculation used the value, and then we went back and changed one of the values. We changed a value in a location, and we let the program update and rerun. So what we're going to do is I'm going to take this kind of a thing, go into the prompt, show you variables, and we're going to have some stuff like this, where we overwrite values, where we check different types of values. But basically, there's a whole bunch of memory, and it's got values in it. Now, one of those things that happens with this is at some location in memory, 2 has to be stored. So there's some location that stores the constant 2. And in some programming languages, C is one of them. I learned that early on. Fortran is another. You may actually end up in a position where you can actually change the value of 2 to some other value, like 9. And believe me, if you change the values of your constants to other things, this will not make you happy. This will cause you great confusion. But it is possible because everything that's a value, like 2 or 3, has to be stored somewhere inside the computer memory for it to use it. So it's possible that you can actually change these things, tweak them. It doesn't happen much in Python. That's a good thing about Python. But sooner or later, you'll run into a case where it's just wrong because things have been tweaked. All right, let's get on the computer and let's actually run some examples and work through this. Okay, let's play with some variables. Now, I've brought up a shell here on a Macintosh that is configured to run our Anaconda Python, or you could bring up a shell on your Windows system like PowerShell or the Bash shell from installing Git. Any one of those will work. And I'm just going to go into Python. And this is a good way to, if I can type Python, this is a good way to play around and see how things work. So I drew you some diagrams of this is what's going on in memory. So you've got some idea of the architecture of the machine. And we talked about constants and variables. Now, in Python, we can access a variable by just saying some variable, that's the name of it, equals 4. And interactively, I can find out the value by just typing in the name. It'll just print that out. So doing just v there is just like doing print v. That's the same thing. That's what it does when you just say, here's a variable, what is in it? And this is really useful for being a nice calculator. For instance, if I want to find out if v is the number, okay, this can be a useful thing in and of itself, because unlike, most calculators, Python is willing to calculate with numbers that are quite large. So we could say v equals v times v, and find out that that's bigger, and we could even do much bigger. And find out that we have a number that is large. And you go, does anybody ever use numbers like this that are this large? And the answer is absolutely. If you've ever been to a site like your bank and they're doing HTTPS, they're using numbers that are way larger than this to secure your communication. A normal HTTPS RSA key that it's using for this is 2,048 digits long. That's the small size. If you want real security, and I sometimes do, I use ones that are 16,000 digits long. So yeah, it does numbers like this, and this can be a lifesaver in a lot of classes when you do a calculation, and you can't approximate. You actually need to do the numeric calculation. So this is a useful thing, as just being a calculator. So, sometimes you want to be there. But we can also say that we have some values that are strings. And we'd like to be able to stick strings together. Now, an interesting thing is that we have operators in the language. Now, you've noticed I'm using a star to do multiplication. And we're going to spend some time going through the different operators that you can use. But, sometimes you'd like to have just, like v plus 2. Which, you notice, if you compare the numbers, it got 2 larger. But what happens if we add strings? If we say s plus t? And you'll notice that instead of it adding numbers together, this plus operator does something quite unique. It stuck the two together. It's kind of an addition, but it applies to strings. Now, so far I've just done integers. That means it doesn't have a decimal point, and strings. But let's say you want to do something with floating points, like f equals 1.2. So I want to stop there and point out that we have different data types again, and they have different behaviors, because I can do f equals f plus 3 and find out that f is now 21. So addition applies in the context of what the variable is. And multiplication and division, all of these things operate differently depending on what the type is, which is why the type of the variable becomes suddenly really important. For instance, I can't say f equals f plus 3. I'll get an error because it says on one side I have a float and on the other side I have a string. Now, Python is what I'd call a fairly loosely typed language, and typing is really important for getting correct programs. I frequently use languages like Go and Haskell that are very strongly typed, and it prevents errors much more than Python will prevent errors. And you can have type conversion errors in Python, but you got to work at it. Whereas in a strongly typed language, if you don't get the types right, the program doesn't run. It doesn't run at all. Now, here we've just worked with, some variables and some numbers and some stuff, but I want to concentrate a little bit more on strings. We're going to use a lot of strings before we're done, and we want to do things like, we'd like to take Tim Smith and actually put a space in there. So let's say that we have s plus a space plus t. So we can do that. Now, if I want to capitalize the person's name, we can do s.title. Oops, I did t.title both times. Okay. Let's make that S. Much better. Okay. And now let's say we want to put that into a variable so that we can use it later. So now if we look at SS, we've got Tim Smith with capitalization. Whenever I have a string, there are all these operators. And on most types, there are operators that you can say variable dot something I want to have happen to it. And you notice there's some syntax there. There is variable dot what I want to have happen and 2 parentheses. You can put stuff in the parentheses, and we're going to get some examples of that later, where we're going to use something called format, and we're actually going to put things in between the parentheses to make stuff happen. But basically that says on this variable, and you notice I said this, that's an important word there, on this variable, apply this function. They also call those methods, this function or method, and do whatever it is that it does on that variable and give me back a result. So this is a good way to do interesting things. For instance, we have SS, which has Tim Smith in it. We could have ss.upper and find out that we can convert everything from lowercase to uppercase. Or we could have timsmith.lower and convert everything from uppercase to lowercase. Now, the instant I say case here, this has an interesting ramification. Now, remember from my example, I said everything inside the computer is a number. So capital T is a different number than lowercase t. And there's a method for converting back and forth between the two. But that means that Tim Smith is not equal to Tim Smith there. Uppercase, upper lowercase, and lowercase are different values because the numbers underneath the cover are different numbers. You and I don't pay attention to that. But in Python, the computer pays attention to this detail of these are really different things. So it's important that you pay attention to whether or not the cap lock is on. If you don't believe that, try logging into your university account with the cap lock on, and you'll probably find out, unless you have an all uppercase password, that it won't let you log in. The computer is just going, huh? That's not what you typed last time for a password. The case makes a difference. The case makes a difference in the language. And some programming languages, in the language itself, the case makes a difference. For instance, can I do ss.lower with a capital L? Python is one of those languages. Capital L lower is not a function that is defined. Now, that means that when you go and define your functions, you have to pay attention to the case of the names. And if you put in, a uppercase in one place, you're going to have to put an uppercase in another place. Now, the computer doesn't have any concept of what lower is. It has a piece of code that it says, by golly, SS, I'm going to call it. It's going to do this thing. It's going to produce this result. But there's no underlying value. It doesn't know that lowercase is something or that all uppercase is shouting. And it doesn't care. It's just whatever the programmer put in is what it's going to get for a result. Now, one of those things that's really nice about Python is we can actually substitute in values. And this is, notice that there's an F, lowercase, and then a double quote mark, so that I can say this variable equals this value. It's often the case that if I'm trying to fix a program, I actually want to know what's in that value, like this. And I'm putting in some extra characters so that I know that, by golly, it isn't just Tim Smith. It has these, there's no extra characters around it. I see people all the time try to do debugging, and they don't want to take the time to print out what the variable name is. And they try to do debugging with print statements, and pretty soon their program is big enough that they don't know what the print statements mean, and they're taking more time trying to track which print statement is printing out S versus SS than they are actually fixing the problem. So if you do a print statement and you're trying to find out what's in a variable, it's important you tell us where the variable is, what the variable is, so that you, the human being, can read it and understand it. And ultimately, that is the key piece to communication. Now, I can do print. Okay. Let's do F equals. And let's see what we get out of that. This is a nice way to do print statements when you've got some variables that you'd like to work with. Isn't that interesting? Now, this F quote string, okay, or F string, where it does substitution, uses default formats by and large for things. But let's say that I want right here to have that as lowercase. So when I do that substitution, I can not just do the substitution, I can actually call functions on it and actually manipulate the output. So it is possible to nest this and call it. Now let me point out the syntax pieces. I had print open paren. Remember, when we're going to call a function, it's going to be called with an open paren and a matching close paren. If I go and run this without the matching close paren, something's wrong. I mean, I'm getting dots instead. It won't even let me type it in. If I was doing this in the compiler, okay, it would give me an error message. If I do print and I leave out the curse paren, it says missing parentheses in call to print. And it even gives you an example of what it thinks you might have meant, which is print with an open paren FABC. Now, a lot of things get skipped when it does understand what you're typing in. If in fact I can do print and you notice it's perfectly happy with all those extra blanks there. So there's some sort of an understanding about how it uses blanks and where it uses them and where it just ignores them in the Python language. Part of what we're going to learn is this entire process of how does it understand what we're typing in and what's allowed. What are the operators? What are the functions? For our next homework, we're going to be doing some stuff with strings where you do upper lowercase and some substitutions and use some F strings or some format. And I'm going to show you some examples of using format. Remember, I said when it's an F string, it just uses the default format. That's not completely true, but most cases that's how F works. And sometimes you don't need the default format. Imagine that you've got a variable that has a person's phone number in it, but any zeros in part of the number count as part of the value. Okay, so leading zeros as a number don't generally get printed out, so you may need to format things in a way where those leading zeros count. And they persist. Our W numbers here at the university have leading zeros. And we call them a number, but it's really a fixed length string with leading zeros. And you have to have that leading zero. If you take it out, again, remember the computer matches each one of those things exactly. It's not going to match correctly with the rest of your W number. Everything's going to be shifted over. So that's kind of the essence of some stuff with strings and building it. I want to go on to format. So remember, when we do something and we want a more special format, there is this tool called format, and it takes a string. The first part is the format of the string, which is how we're going to represent this. So if I say ABC equals, and you notice I didn't put anything between those squiggles. You can put information in there that tells it how to do things. And I'm just going to put out a couple strings. We'll take a look at what it looks like. Now, format, generally speaking, okay, the simplest case is it takes these positionally. So the first pair of little squiggles, it's going to substitute for the first parameter out here. And the second one, it's going to substitute for the second one. And this other stuff that isn't in the squiggles, all of this stuff that I'm highlighting, is the stuff that is the text that surrounds the values that we're substituting. And format has the ability to print out a bunch of different things. We could also change this format so that we can actually swap it. We can tell it which one of those variables we want to substitute. And now I've told format that yes, instead of doing it by position, I actually want the zeroth variable over here, which is ABC, and the first variable, which is DEF. And you notice the order has been changed. Format has got lots of options you can set, and lots of things that you can do with the format. So this is like the least that you can see and get away with. I frequently use format in conjunction with print to substitute out a number of different variables and get them in some fashion that I can understand them. And it's right up there with the F-string stuff that I just showed you. But again, notice what we have here. We've got a string, okay? Then we have a dot that says, for this constant string, I want to apply this function format. And then it has a parentheses, and then it has a list. Now, that list has commas in it as separators. So you can put in different data types in the list, but if you leave out the comma, it's not going to be a happy camper. Let's try that once and see what happens. And you notice that it says, I didn't understand that. Again, it's very picky and pedantic about the syntax, and you have to learn the syntax. Whenever you're passing parameters, between each parameter, you have to have a comma. And you don't get the option of putting in extra commas either, which I think is kind of unfortunate. That has a subtly different meaning. I would watch for that. It doesn't give you an error, but it can, under certain circumstances in Python, produce a different result. This isn't one of them. It depends on what the options are for format. Now, print also has a bunch of options like this, and you can use named parameters with print. And when we go in to do print inside our tool, I've got a little program here. It's just basically printing out hello silly world. But if I want to print something, you notice that, okay? And it lists out the options beneath this that I can use. And this is the nice thing about using an integrated development environment, that it's actually helping us. One of those options is end. Down here it says a string appended after the last value. Default is a new line. Now, what is a new line and what does it mean appended here? Normally when I do print, and I'm going to switch back to the other screen here for a second, you'll notice I do print, and it goes, there's a line there. But I can do print, and instead of taking a new line, it still did a print, okay? Let's make this more explicit. Oh, look, it printed it out, but it printed it out and it stuck it on the same line right before the prompt. It didn't go to a new line because this new line here was put in as an empty string instead of as a new line. Now, long ago in the history of computers, the Unix operating system was developed, and one of the things they did in strings is they said we have to be able to print these characters that don't have a normal printable value. And the way that they chose to do that in 1969 was like this. We'll say F equals, okay? And you put in a backslash, that's the slash with the top to the left, and you do N for new line. And now if I print out F, it looks like that. But when I send it to print, it interprets that backslash N in there and says, oh, for the backslash N, I need to go down to the next line of input. So I get first and second on separate lines. Print, by default, uses a backslash N as its new line character, which means that it can print things out on multiple lines. I don't have to do that. I can do something else with the end. Okay? I can stick in something like this. By golly, yep. You can have it separate out its stuff with a big long string instead of just going to the next line. And each time it does that with an end equals like that, it's going to stick in this string. You don't have to have multiple lines. But this set of things with backslashes is fairly universal in most programming language these days. You'll find this in Python, Go, C, C++, a slew of languages because it's been used and worked. Now, one of the questions you should be asking is, if I want to print out a backslash, how do I do it? And the answer is you can put in 2 backslashes. So I can do this is a backslash and print that out. And you notice on the output I got a single backslash. So you can use backslash to escape itself. This is all good and fine for most stuff, but somebody in their confused moment at Microsoft, actually before Microsoft existed, decided to use backslash for a separator for file names and directories. And this has turned out to be a horrible choice because most operating systems today are running some form of Unix or Linux, and they all use slashes. Macintosh is sitting on top of a Unix system, as is the light bulb behind me, and my microphone here beside me, and my Samsung monitor, and my Kinesis Freestyle 2 keyboard are all running Linux. Or my Mac is actually running BSD Unix, which is similar to it. And all of these things use slash as a separator as opposed to backslash. So quite often you will find in programming languages that if you want to put in a path name for Windows, you end up with something like this. And the reason why you have to put in double backslashes is because you've got to escape the backslashes so that they will actually be in the string. Some programming languages, Python is one of them, will actually take a slash as a separator and they will convert it to the appropriate backslash if it's used in the context of being a file name. So that's a bunch of different things and how to use format. There are, I think, 38 different options on format, and you're going to have to look them up if you want to use some of them. But you need to be aware that there is a tool for formatting stuff, because someday you're going to want to build a report and you're going to want things to line up when it prints out. And to get it to line up, you're going to have to add spaces in the right places. And you're going to have to print things in certain widths. And as soon as you do that, you're no longer looking at F strings, you're looking at how you're going to use format to get the correct layout for each line of text on entire pages, each page of text, things like that. So format is super powerful and super useful, but 90% of the time I just use F strings for printing stuff out because I don't have to get the perfect format and perfect layout. The last detail is I'm inside the Python interpreter. How do I get out? Now, there are 2 different ways of doing this, and one of them is dependent on the operating system, and it's important that you know it. On Windows, you do a Control-Z and a return. On Linux systems, you do a Control-D and a return. There is the other way, which is typing in quit, open paren, close paren, which calls the quit function, which allows you to get out. But the Control-D is a end of file on the input file that you're reading from, that the terminal is using. So it doesn't just work in Python. If I'm in a bash shell and I do Control-D, yes, the shell disappears. It just exited because it came to its end of file marker. And that's also true for lots of things in communication in Windows. And if you're using bash on from Git on Windows and you do a Control-Z, it will be end of file and it will exit out of the shell.